Welcome to Study Loop.
This is the answer to Chapter 21, problem number 52 from the Smith Organic Chemistry textbook. And in this problem, we're told that A and B both readily cyclize, but A gives an optically inactive product, and B's product is optically active, and we are asked to account for this difference. And so we're also asked to draw the products, draw the stereoisomers. But honestly, even if we weren't asked, that would be really the only way to approach this problem. And so the first thing we can do is, it's a really ugly ring. I apologize. I'm going to redraw that. So the first thing that we can do is just draw the product of A here. And so we have a new stereo center that's been formed at that carbon. And so really what we're going to get is this molecule, and it's an enantiomer. Okay, and so these are going to be formed equally. So this is an equal mixture of enantiomers or a racemic, however you prefer to say it, racemic mixture. And we should know that racemic mixtures are not optically active. Okay, and so that accounts for A, not being optically active. And then when we look at what the product of B is going to be, B is going to cyclize to a 5-membered ring. But the difference is going to be that we have defined stereochemistry at this position. So the green position is defined or set. And then again, we have our new chiral center that I'll indicate with a red arrow as I did above. So we have our new chiral center, but it's in relation to an existing set chiral center. So what we're going to get here, just give me a moment to draw these out. So here we go. So what we get here is not a mixture of enantiomers. What we get here is a mixture of diastereomers. And so a mixture, an equal mixture of enantiomers is a racemic mixture, but an equal mixture of diastereomers is not racemic. And so they're not going to cancel out each other's rotation, as is the case in a racemic mixture. And so this is a mixture of diastereomers. And so this is optically active. And so that's the difference that accounts for the non-activity of A and the activity of B. B has a set chiral center already, and therefore the products in B are a mixture of diastereomers. A does not have that set chiral center, and so the products for A are a racemic mixture of enantiomers, and therefore not optically active. And that's the answer to chapter 21, problem number 52.